Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just resolved on my own after over a year, so I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So you can see I first solved it last September 19th, 2024, and I just did it by myself a couple minutes ago. So let me show you how I did it. This is question 1513, number of substrings with only ones. So basically, you want to count the number of substrings that have only ones. So pretty straightforward. However, you'll notice that each is either a 0 or a 1, which means that we can do better than n squared. So the first, most obvious approach is just to go over each substring and ask if, well, let's do this. And then we just count the frequency of the characters. So if we have, let's say 1, how many we have, and then 0, how many we have. And then we can just say, as long as there's, if length of C is equal to 1, and basically there's only 1, right? So if not C of 0, then we can say there's one more valid substring, right? Otherwise we break, because for example, if there's already a 0, then the rest of the substrings will also have 0, so there's no point in continuing this loop. And at the end, we can just return answer. So this is fine, but this is going to be really slow because it's n squared. And as the input size grows, this is going to take exponentially more time. So let me show you the approach that I came up with to optimize this. So basically, because we only have zeros and ones, notice that a segment should have a sum equal to its length, 1, 2, 3, if they're all ones. So that's the key insight that I observed. And so let's go ahead and do that. Let's go ahead and iterate over S, and then we're just going to append an integer so that we can actually accumulate the sum, right? So this is using prefix sums. So if we print P, you can see that we have basically the sum up to the current point from the beginning to the current point. So then basically the idea is if we loop over S, let's run a binary search, right? So let's try to find, if we're looking for some substring, instead of counting all them manually, let's find the point to the right where there's still going to be all ones. And as soon as we find a 0, then we just break it, because we're going to keep searching for basically a spot that doesn't have a 0, which means that the sum is not happening to be equal to the length because there are only zeros and ones in the string, right? So let's do that. So I, length of S, or length of current, minus 1. Okay, so these are the same things. They're just a list in terms of integers. And so the binary search, we're going to observe the midpoint. And remember, for prefix sums, if we're looking at the sum of this, it's just the whole thing, because there is no left side, right? Versus this prefix sum of this is just prefix of this minus prefix of the one right before for the prefix sum of this. So prefix this minus this gives you the prefix sum of this. So if I is less than or equal to 0, then the subarray sum is just going to be P of mid, right? Otherwise, subarray sum is P of mid minus P of I minus 1, because, for example, 1, 2, 3, 1, 3, 6. If we want the prefix sum of this, then it's 6 minus 1 is 5. That's the sum of that segment, right? So if the subarray sum is equal to the size, which the size is just going to be mid minus I plus 1, then this is a valid point, and we want to move our left pointer up. Otherwise, move the right pointer down, because we can still extend the subarray in this case, because, for example, if this is still fine, then we can keep trying to find a longer one. That's possible. In this case, it's not, but if this is fine, we're still trying to find a longer subarray, so we move the left pointer forward, right? So, okay. So then, in this case, let's go ahead and actually create a sorted list, because we want to keep track of all the valid points. So let's add mid plus 1. right? Because the size is always one more than the index. So let's go ahead and print I and SL. So this should give us a clue of what we're looking at. So for example, 0, 1, 2, 3 is not valid. So maybe we should actually use mid instead, because mid is valid. So you can see here 1 to 2 is only valid, 2 by itself is valid, and then 4 to 5 and 6, 0, 1, 2, 3, 4, 5, and then 6, right? So the whole segment from 4 onwards is valid. So in that case, if SL, then we can just add to our answer SL of -1, right? The rightmost minus I, right? And that's fine, except we have to also add 1 because of the lengths, right? Okay, let's go ahead and submit this. And I forgot the mod, which is important, because it says that right there. It may be very big. And so this takes the time complexity from n squared to n log of n, right? Because binary search is log of n. And then let's go ahead and run this again and submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to resolve this question completely on my own without any assistance after over a year. So that's it for this video.